Oh, we're live.
Okay. All right, we're live, but we don't have any viewers yet, so we'll maybe hang on a sec. Oh. Well, I guess it's 11. We can start, and then it will be broadcast later on YouTube if people want to watch it later.
Sure. So I'm assuming the invites went out there, or people's computers should be ringing.
Yeah, so I put the invites out when I sent it when you got your invite. And people, yeah, who said that they were going to watching, they should be getting some little updates that it should be starting now. So we can also see how many people are in the Etherpad, if anyone. So there's 4 or 5 people in the Etherpad. Okay, I can see Cam is in the Etherpad. And
someone's requesting an invitation.
Okay, I can add Raina.
Chat.
Okay, so the invitation's been sent to Raina.
We're not adding ourselves.
No, yeah.
I mean, you can check, chime in on the Etherpad.
Right.
Yeah.
But not part of it.
Hang out, I guess.
All right. So should we get started?
Yeah.
All right, cool. I guess since there's only 3 of us here now, we have enough time to do like a short introduction of ourselves.
Yeah, sounds good.
I'm Daniel. I am a graduate student in the Genetics, Bioinformatics, and Computational Biology program here at Virginia Tech. I got my master's in epidemiology at Columbia, and I had a year in between where I was just doing general data analytics work. And I've been involved in software carpentry for, I guess, 2 years now, very actively teaching, according to some people who get instructor accounts. So yeah, pretty much everywhere I go, or even during my previous job, the stuff that we teach at software carpentry is really, really important, and they're just skills that people don't have, or they don't have a full understanding. And sort of this was inspired a lot of Greg's talks about we should just have a common set of material and teach off of that instead of everyone, every September 1st, there are millions of teachers writing like a Calc 1 lesson plan or something. So, and since all of our material is out there, and it's been tested for quite some time now, it seems like it would be a good foundation for universities to pick this up. So I guess that's why I had this proposal to make this roundtable discussion. So.
Fantastic. So I'll introduce myself next. So I'm Tiffany Timbers. I'm a postdoc at Simon Fraser University in Burnaby, British Columbia. And I've been a software carpentry instructor for, I guess, almost a year and a half now, and taught 5 or 6 different workshops. And this past month, I've had the opportunity to teach an undergraduate course to about 3rd year undergrads on computation in the sciences. And that has been an intensive 3.5-week course to teach an entire undergrad course in that amount of time. And then with me here is...
That's definitely. I'm Jenny Bryan. I'm stat faculty at UBC, and I've been the lead instructor for 4 or 5 software carpentry. And at UBC, I teach 2 grad courses that have a lot of software carpentry elements, though they are by no means software carpentry courses. So one is data analysis or exploratory data analysis, and the other is statistics for genomics. And we end up teaching a lot of software carpentry stuff in them. So.
Yeah, cool. So I guess I guess I'm sort of like the MC and asking you guys questions and stuff. So for everyone else who will be watching or currently watching, this past year, Katie Huff and Anthony Skopaz just released their book called Effective Computation for Physics, I believe is the correct title, by and it's out through O'Reilly. And my understanding is they put together, I guess, a syllabus around that book, and you, Tiffany, are their first, I guess, guinea pig to beta test.
Oops, I think you froze up, Daniel. Just see what's happening. Well, maybe I'll just comment.
Answer a question you want to answer.
Yeah. So as Daniel said, Katie and Anthony wrote this book called Effective Computation in Physics, and they based a lot of it off of their experiences teaching software carpentry, as well as I think Anthony Skopaz has taught one of these intensive courses at the maybe master's level to students. And so I decided to use this textbook as the textbook for the course that I was teaching up at Quest University. And it's been quite interesting. So it starts off with a first chapter in the and then it moves into, it's based on Python, but it carries through a lot of the principles that you would be using regardless of what language you're teaching. And it also covers version control, automation such as make, and as well as talking about documentation, licenses, open science aspects. So what they've also done with this textbook is they've created a collection of or a GitHub repository that has IPython notebooks that have the code required. Oh, you're back.
Okay.
I've just been answering the question I think you were asking. So, so I just said that yes, Anthony and Katie wrote this textbook, and I've been using it. I went roughly through what's in the table of contents. And then the next thing that I was saying, Daniel, is that in addition to this textbook, Anthony and Katie have put together a GitHub repo that has a collection of annotated code in IPython notebooks that people who use this textbook could use as basis for their seminars or their lectures or their classes. Are you still there?
Yes, I am still here.
Okay,
Great. The questions, so I guess when I sort of put in either side, there was like a discussion I brought up like last year or 2 years ago, and one of the comments a lot of people returned back with was it's great that like you want to like have a conversation with the course, but the biggest problem is administratively how to get this like especially like if you try to put a class up like this, or one of the comments was the computer science department is like.
Sorry, Daniel, we're having a hard time hearing you here. Maybe.
Hello.
Yeah.
Is that a little better?
A little bit better, yeah.
Okay, so one of the problems or questions or concerns brought up about trying to start a course like this is administratively how do you get the university to do the course?
So your question is, how did we get the admin on board for this course?
Yeah, or like, did you have any problems with other departments claiming like this was their jurisdiction?
Okay. So for my experience, that wasn't an issue because Quest is a liberal arts college and they don't have a computer science department. This is essentially the only computer course that they're offering this year. But maybe Jenny can speak to that.
I just sneak it into courses that are already on the books. That's my approach, because I have created a course from scratch and it was a nightmare. And yeah, so my cynical strategy is to just teach it in courses that already have a number, but that's not a long-term solution. I think it would be a good idea to get something like this officially on the books. But it's better that you've piloted it in existing courses or in a topics course that you can park any content in might be the way to do it first.
So I guess my next question is, how would other people go about piloting something like this? So both of you are more at faculty or staff position, and I guess I'm a lowly graduate student in tech. So would one way, like for other people listening, and like I imagine if I get some faculty members to sponsor this project, how would we go about piloting? Like, would it seem feasible to sort of just have like like a 1 credit self-study course where we sort of teach this material through? Like, would that seem like a way we can put this through?
Well, so if someone at UBC wanted to offer this and they weren't me, like they didn't already have teaching obligations and rights, maybe you could pitch it as a topics course, and like at least in our department, those can be variable credit for 1 to 3 credits. Or I also wonder if you could find an instructor with a course that seems related and basically offer to teach a lab for them. And so the computational part and the software carpentry material could be sort of sold as the computing lab for an existing course maybe, and get some of the content created, and that would get you paid as a TA and all sorts of things like that. That might be another way to sort of bootstrap it.
Oh, right.
Yeah, I can't comment much more on that because Daniel, I'm also I'm a postdoc at SFU, so I don't really have any teaching responsibilities at my home institute, and I'm the course that I'm teaching, I'm filling in as essentially a sessional position for them. So.
So I guess I spoke to Bill Mills roughly when we were at the mentoring, like right before the official mentoring committee meeting, like a few weeks ago. And one of his concerns was to take the software carpentry material and how do we fit that into 30 weeks, which is a typical like length of a course semester. And my question was, do we take the current material and make it 2 or like a half semester course, so they only cover 50 weeks? Or do we sort of expand it to 30 weeks? But the problem with 30 weeks is he wanted to make sure it doesn't all of a sudden become like, it doesn't like leave the software carpentry material like too much. Like he said that a lot of times it becomes like a big machine learning data science heavy course. And you could probably just stick with fundamentals and let other courses stick there more heavy.
Sorry, I didn't catch that last half of your question. It's a bit quiet. Can you speak up a bit?
Oh, so I guess it's really how should we, what would be a good way to take the current material and put it into the 30-week or 15 or half semester section? Because Bill did bring up the point that he worries that a lot of time people who try to teach a course like this it ends up becoming like a heavy data science or a machine learning type course, and we should probably just stick with the fundamentals. And given that were the case, how should we break up the current material? Or do you guys have an idea of how should we break up the current material?
Yeah, I can comment on just what I've taught. So what I've taught is over 3.5 weeks is supposed to be the same amount of hours as a full semester long undergrad course. And so what we did is we covered, like for the software carpentry material, an abbreviated shell. We did 6 hours of version control because I had them do, it was split up, but because I have them do code review as part of their, as part of the course, they really needed to be able to send pull requests and accept pull requests from each other. So that's why we did more version control, but these sessions were split up weeks, like it's a week apart. Mm-hmm. Then we also covered basically all the Python basics that were covered in software carpentry, and we did go heavier. I mean, Bill is right. Data munging and visualization I think is really important and what a lot of researchers and scientists spend a lot of time on. So we spent extra time on visualization and using, for example, in Python, the pandas package, which gives a lot of the data frame capabilities that R has. And then because I think that you learn a lot by doing, for maybe almost the last equivalent to 9 hours of the course, the students are kind of doing hack sessions together where I'm present to help them work on they have a final project that they have to do, so that I'm not actually teaching and like leading a session every day. Part of that, why I get to do that maybe is because Quest University is they actually don't like lectures. They don't want anyone to lecture, and so they want a lot of active learning happening, so they're very happy with that kind of situation. But I don't know if that would work at other institutes. Jenny, do you want to comment on?
I don't know that I have that much to say because I'm not teaching classic software carpentry material, or I'm sneaking it in basically as we go. But I think one thing that would be nice about spreading it out over longer time is you could make some of the examples less artificial. That's always been a bit of my complaint with some of the software carpentry stuff, is because you have to move through so much technical stuff. You're doing lots of things with like the file foo and like these sort of really unrealistic artificial examples. So the nice thing about spreading it out is you can give that bit of technical instruction and then give them time to try it on an example that's not super boring. And so I think that would actually be a really nice feature of spreading it out over a semester.
So I guess to build on what you said, Jenny, how do you keep your current SAS courses, or how do you shimmy in the software carpentry material?
Can you just repeat that one more time? Sorry.
So how do you keep your courses, or how do you incorporate the software carpentry material into your existing classes?
Well, so I mean, I have a lot of material that I use in both settings, and so I always use one as an excuse to make me develop it a little further so that I can use it in the other setting. So I'm mostly teaching R and data analysis in this course. So then the part where software carpentry material is very helpful was the Git material, although I don't teach a lot of Git. I probably should spend more time on it the way Tiffany does. We do a lot more of just like learning by doing than like, I've never drawn those charts on the board that I see from some software carpentry about parent commits and blobs and staging and all that stuff. I actually avoid that. I don't know if that's good or bad, and they do manage to like get the work done. But so I haven't explicitly brought software carpentry lessons into these courses yet. Yeah.
Hold on, let me see if there's anyone. Are there any other questions from the group chat?
I think I had a couple questions that I would like to ask Jenny, and I would maybe like to ask anyone if they have any ideas. So in teaching this course, I come from a biology genetics background, and so I've never got to TA a computer science course. And the last computer programming course I took as a classroom in the classroom was when I was in first undergrad. And so I was really curious on how do you best, like if you're teaching software carpentry or programming for research as a graduate or undergraduate class, you have to assess people. And so what's the best way to assess these skills?
Oh, like how do I mark their work, or how do I assess them on the inside?
So both, like what assignments do you give, or quizzes, tests do you give, so that you can get an understanding of if they've learned and how much they've learned? Yeah. But yeah, those kind of strategies.
So I don't do little quizzes.
Yeah.
Some of that's just like, because I'm overwhelmed with the amount of work the course is already. So, and I used to have big giant projects at the end, which I discovered causes a dysfunctional amount of heroic effort at the end of the course for students and for me. Mm-hmm. So they would leave stuff till the end and then pull 3 all-nighters in a row, and they may or may not really get it all done. And then I would have, 40 or 50 special and unique snowflakes that needed to be marked that are not very amenable to a single rubric. And so I've evolved over the years to a different model, which is there's a homework assignment that's really more a set of prompts once a week. And it's just like a constant IV drip. Like you're just trying to work at like a constant level that's neither heroic nor slacker for 12 weeks, which is hopefully a little more what real life should look like. And I can have a pretty standard rubric overall, and then I can apply the same rubric to everyone. And I've found that to be easier. Also getting TAs, some of whom are back there, to do the marking has been helpful. Last year I did half of it on my own and I nearly died. And peer review is invaluable. And that's a great thing if you've got them set up on Git and GitHub. You can use all this like GitHub machinery for assigning them each other's work and having them comment on commits or in issues and make pull requests, whatever. And so I think I've shied away from the giant project and the perform in a limited amount of time sort of thing. And it's just all weekly homework and tons of peer review. Yeah.
Oh, that's really interesting. So, go ahead, Daniel.
Is my mic a little, is it a little better, like microphone wise? Okay. Yeah. I guess to build on, I guess that, like, so circling back to the book. So the book is actually has the word physics in it. And I know that both Katie and Anthony try really hard to say it's not just for physicists. O'Reilly just wanted them to have a concrete example. And since they were both physicists, that's the examples they use. So there's a lot of chatter in the Etherpad about what department do we put this under, or should we limit it to a certain department when we teach this course? So I know, Jenny, your course is in statistics, and it's not really software carpentry only material, but is your stats course open to people outside of statistics? Like if I was in a bioinformatics program and, you know, pretty much everything needs statistics, like is it closed off to just stats people? And I guess the same question to Tiffany, and like who's allowed to attend your courses, or who's it really for?
Yeah, so mine's wide open to any grad student. And I have undergrads, but I have to sign some form for them. And I actually have tables and figures on the web, so I'll put them in the Etherpad after on the enrollment. But since I've been tracking it, I've had people from 50 different programs. And I think 25 have sent at least 2 people. So I have good stats on who's there, and they're basically just like all over the map. Like, so 40% cumulatively are stat students, because I usually have all of our incoming master's students. And then it's just like everything else. But computational biology, bioinformatics is very well represented for sure. But I have people from all over. And I think that's good, actually, for the course, to not be hyper specific. All right, so I'll let Tiffany go.
Yeah, so for this course, I was hired by the Department of Physical Science at Quest. And so I'm using Katie and Anthony's books, which you're right, is based on a physics example. But despite the course using a physics textbook and it being labeled a physical science, it was actually labeled computation in the physical sciences. I have a wide, there's only 13 people, class size is capped at 20 at this university. And yeah, it's lovely having only 13 people. I can't complain about that. People are from all different aspects. So I have people who are interested in biology. I have 2 physicists. I have some people interested in oceanography. I have someone who's who's doing marketing projects, somebody who's doing a sociology project looking at voting and lifestyle. And it was interesting. So I was asked, we have what they call a mid-block review. So the students lead a feedback session on the course and on the teaching. And so they let me listen to half of their discussion. And they started discussing the textbook. And it was cool because they were asking each other if they're reading the textbook and if they like it. And I just got to be a silent observer. And they all really liked the textbook, even the sociologists and the marketing students. They all thought it was very, very relevant also for what I was teaching in the class, even if I wasn't teaching. So like, for example, for some of it, instead of teaching the seminars, the GitHub seminars that are associated with the textbook, I decided to teach the software carpentry material because I was a bit more familiar with it. So I was using the inflammation data set, and Katie and Anthony had a different data set and different examples, but covered the same topics roughly. And they really liked, they still felt it was extremely relevant. So I do think that the textbook could be used for a variety of topics. It doesn't have to be for physics, but you would have to, but it's very Python specific. So you would have to be teaching Python. The shell part and the Git part would be relevant for other things, but the majority of the textbook is, or at least half the textbook is focused on Python.
And hold on. Cool. And then I'm just sort of just going down the questions that are showing up on Etherpad. One of the comments was, so what does the first, I guess, few weeks of the course look like for you guys? Because at least the way the software carpentry material is set up, it's really, you know, how do we get like that pretty graph as fast as possible, so they feel like they've accomplished something. But you know, everything's already so condensed when we run our software carpentry workshops. What do the first couple of weeks look like in your courses, or how do you spread out, you know, some of the fundamentals like Bash? Like you need to be able to get around your computer first. And how do you, or do you just teach all of Git in one go, or do you sort of, you know, stagger a little bit of Bash today, sort of introduce them to Python, and slowly incorporate Git as you go on through the semester?
Well, yeah, so I have the liberty of teaching data analysis. So like the first thing we do is we make figures because it's so motivating. So we make figures early. I start with the cleanest data possible. And it motivated me to turn my data into an R data package so that we can just install it with the usual mechanisms. And then I feel like I slowly reveal all the horror and ugly underneath. Like week by week, I'm like, all right, well, I hid this from you, and now I'm going to show it to you, and you'll see what it takes to get data into this form. So it actually feels like I work backwards a lot, so that we start from a very happy, eye candy, motivating place. And also, like, we just get them to edit their README on GitHub at first. And they're like, oh my God, I've made a web page. And it's not till the next week that we learn how to bring that local, edit it local, and push it. So I'm very much about success, pretty, something's on the web first, and then slowly develop the tools underneath. And so again, I have the luxury of doing that because I have 13 weeks. But yeah, I think thinking about motivation is really, really important.
Yeah, I agree with Jenny that the motivation is key to getting students engaged and on board. So I, unfortunately, with this course, didn't have the luxury of 13 weeks, so everything is taught in 3.5 weeks. It's the only course the students are focused on, but you miss the ability for them to consolidate. So that it is a bit more like a software carpentry workshop for 3.5 weeks straight. It's
on steroids.
On steroids. It's pretty intense. So how I decided to teach it, so I discussed with Katie and Anthony beforehand just to get, and Bill Mills, I consulted with these people to get their opinions because they've done a lot of teaching, more than I have. And so Anthony teaches Git directly after, when he taught this course, directly after the shell. And I decided to do that for 2 reasons. One was based on his advice, and the second was that I wanted them to submit their homework that I was going to grade via GitHub. So that was going to make it easier for me. So for the shell, we did an abbreviated shell up into basically being able to navigate the file system and creating things. And every night, their homework was to basically, I did go with this big final project, and I haven't marked it yet, so I might regret this and never do it again. But
you'll learn. I did it like 2 times before.
And so what they do is every day we learn something for 3 hours, and then their homework is to go home and implement that on their final project. So on day 1, we learned how to navigate the shell, how to create things, and how to write shell scripts. And so they had to write a shell script the first night to set up a directory structure for a project. And so that was their homework. And then we did Git the next day. And so then their homework was to make a Git directory of their final project using that shell script. And it built on from there. Yeah. And so I guess talking about motivation, going back to that, we didn't get to visualization until near the end of the fourth or fifth day. And so what I tried to do was at the beginning of every class, give a big picture of why they're learning this and where it's going to take them. So for example, even the first time we learned GitHub, before we even start, I would show them websites hosted on GitHub and say, this is a motivation to learn this tool, because eventually you can make this, you could make something like this yourself. And then show them organized code repositories and say, look at this lovely organized project with this nice README that's formatted well, and you can see and make sense of everything. And so we're going to learn this tool to be able to do that. So there's always, like Jenny said, give them big motivation, because sometimes it takes quite a bit of effort and brain crunching to be able to understand these things.
And just, I guess for people in the future watching, so the data set, Jenny, correct me if I'm wrong, that you put up on CRAN for R was the Gapminder data set?
Yeah, that was the one that the course motivated for me to package it nicely. Exactly.
And then for
this year, we're gonna put another one out that's even more exciting. Give me a month.
Yeah, and then I guess for the Python or non-R folks, do you know how we can get that in a CSV form, or?
Oh, well, so I include TSV versions in the package itself, and therefore you can, assuming, I mean, there has to be a way to just
like pull it straight from CRAN?
TSV from Python, like they're up on GitHub, for example. And I also put them in like non-HTTPS places, so they're easy to grab.
Yeah, I think you can do that with pandas. And I think that Nancy Sutjens from UBC has developed a Gapminder lesson for Python that she taught at the Women in Science workshop that happened here earlier this year. I don't think it's on the Software Carpentry repo, but if you go to her repo, you should be able to see it.
Okay, and then this is my last question, and then I think we should probably figure out how we can get people involved, because there's like invite issues.
Okay.
But so Jenny, you teach a 13-week course, and Tiffany, you teach a 3.5-week course. So what does how many times a week are you doing it, or how long is each course, and roughly how much time you devote to each topic? So like, for example, like my initial thought when I was thinking about this was, okay, let's try to make this a half semester course and maybe run it twice. So you can either have people, take the course twice just because, repetition will help them. Or, you can have an R section for the first half of the semester and then a Python section for the second half, depending on what they need. So roughly for 15, Bash is, when we teach our workshops, it's 3 hours. And if you treat that as, hold on. Yeah, so Bash, if you devote 3 hours, Git, our lesson, a lot 3, but I almost feel like if you want to get them to know a little bit about merging and branches, you need another 3 for that. So Git for 6, Python R, just to get the introductory, like how you write a function and loops. If you put in another 6, that comes out to be 15. So if we do 1 hour a week, that will cover 15 weeks. But 1 hour a week does seem really, really little. So how do you guys break down your course, like your classes, in terms of hours?
So yeah, we're doing 3 hours of teaching a day every single day. So we did 3 hours of Shell. Is this what you're asking me for?
Yep.
Sorry? Okay. So we did 3 hours of Shell the first day, 3 hours of Git the next day, and then every other day except for about 2 weeks, we were doing Python for 3 hours a day. And it depends. I think it depends how fast you go through the material, how quickly you move, or like how much active learning exercises you implement. So it actually took me about 9 hours to get through loops, functions, and if statements, because I had a lot of active learning exercises and I really wanted them to grasp it. And for example, like testing took another whole 3 hours we spent on testing in the third week of the course. And then after, so I spent about 2.5 weeks where basically I was teaching software carpentry type style. And then since then we've moved into doing code review. And so what happens with that is that at night, each student is given 2 other students' homework projects to review. And then I sit down with that group of 3. So they're broken up into groups of 3. And they each have to give 5-minute summaries of the pull request they sent to each other in front of me, and we have a discussion. And so I meet with each group individually, and while I'm doing that, the other students are back in the room having like a hack session where they're all working on their final projects and they're allowed to chat and ask each other questions. And yeah, that's how essentially I break up the time.
Again, so I mean, I'm teaching less classic software carpentry stuff. So I would just say, I mean, I have 3 hours of class time with them each week, and it's maybe 30% I'm maybe walking through some slides to set the stage, and then the rest we're working in R, or I'm working in R. I'm hoping they're following along. Sometimes we pause and everyone literally is working in R, but so the way I view the class time is like that's really not where they learn the bulk of it. It's doing the homework. It's like all this outside time is where you actually learn it. And so I just think of the class time as giving just enough information and like pointers to where I've put things on the web, so that when they sit down to do their homework, they don't just weep with frustration and hate me. But it's only when they start to sit down and engage with it that they'll figure out if they're gonna learn it or not. So I actually don't stress too much about the class time, or I don't think that's where the learning's happening anyway.
Okay, and my last question, I promise. What final projects do you have the students work on? I guess this is more addressed to Tiffany, but since it's, but Jenny chime in as well. And
Final projects.
like, is it like, do they pick a project, or do you sort of assign like, you know, something that like you have to use Git to create a shell script that makes this kind of folder structure and pulls in this kind of data, and then you use Python to, you know, generate a plot or something, like, or do they just pick something that, you know, that they come up with? Like, what kind of questions are they, or what kind of projects are they working on?
Yeah, so I think I've been extremely flexible with this, and maybe I shouldn't have.
You will regret that.
Yeah, so what I've done is I had them think about their final projects the very first week of class, and even if they hadn't decided on one, like I said, on day 1, they had to make a directory structure for the final project, and every homework assignment was related to it. But the only kind of caveat the only really instructions I gave them for that was that essentially they had to pick something. I wanted them to probably pick something in an area that they're interested in to keep them motivated, and that they're supposed to have a research question they're interested in answering and a hypothesis, and they have to do something. Essentially, I wanted them to do something that's challenging to do without computers. So if you didn't have a computer, it would be really hard to do. So, but these are undergrads, so I get my expectations aren't extremely. They haven't had really any research experience, so I have a double barrier there. So what they need to do for their final project, for code-wise, is that I'm expecting them to write a Python script. That Python script should input data, and then save a plot and or a table out of it of some sort of analysis or visualization that they've done. That script, like I said, has to take input, and then should take input for what they're going to name that final file. And then to have a record of, because the script is flexible, I want them to wrap that in a make file or a shell script, so there's a record of exactly what the input and the outputs they gave to that file. They also have to write a 2,500 word report, because what's the sense of doing computation if you can't disseminate that information? So you tried to answer a question with a computer. What did you answer that question? If so, what does it mean? And then they're, because I wanted them to show off to each other what they did, they're going to give a little 8-minute presentation of their project as a IPython notebook at the end of, on the last day of class. But as Jenny says, I probably will regret all of this flexibility.
Okay, and I guess just extending off of the final project, I mean the report part, how much of literate programming, or when do you introduce literate programming? And for those who don't know what it is, literate programming is a means where you can have regular prose text and sort of interweave code and code output in the same document. So when I teach my software carpentry stuff and I get a R workshop, I almost show them knitr like extremely quickly, because it's easier for me to break up parts, but it's also another way for me to sort of show them what Markdown looks like, and that sort of makes Git, that's another reinforcement on Git. And it's also my way of trying to convince them, like, hey, you don't need to use PowerPoint anymore. Like, you can just write everything you want in R. So do you, Tiffany, like introduce literate programming in Python? I guess the easiest way is to use the notebook, and I tried to give, I did give a SciPy talk this year on pweave as like a literate programming way for Python. So do you teach literate programming in your courses?
Yeah, so I mean, so I get them coding in the notebook, and slowly throughout the first week, I kind of show them markdown cells, but don't expect them to use them, but they see me using them in front of the class. And then in the second and third week, when I asked them to do homework, for example, so we taught them how to do some statistical analysis. Their homework is to go home and do to pick a statistical test, apply it to their data set, and then in a markdown cell, explain why they chose that test and what they think the interpretations mean. So and then hopefully by doing that a few times, they kind of learn a little bit about interspersing the markdown. It's interesting to see at the code reviews, they're telling each other to do it. They're like, this would make it a lot easier for me to review your code if you wrote in a markdown cell. Yeah. And so they're pushing each other to do it. And then as I've given them clear expectations that when they present their final project, it's not PowerPoint, it will be in a Jupyter notebook. So I think they're well on their way to doing that. But yeah, I didn't like give an explicit class on how to do it. It's just kind of like fallen in through the notebook. It would be different with R perhaps though.
Yeah, so like you, I teach all Markdown. Like, I think we're using it on day one.
Right.
It enables you, once they've made the plot and they're so proud, then you can make a web page, and then you can get it on GitHub very quickly, and that is just so rewarding. And what was the other thing I was going to say about the literate program? Oh, the peer review is also super helpful for this, because when you go look at someone else's repository, if you can't find their homework, or you can't figure out which code made which plot, like, it's very frustrating. So I think then people come back and look at their own work and repository a bit differently the next week. And so I think constantly having to interact with other people's work indirectly causes a lot of good habits to happen, because they're contagious. And you feel the friction when people don't organize their stuff. It's hard to figure out what you're supposed to be looking at or what to say about it. So I think the peer review helps.
Okay, and I guess now would be a good time to try to get everyone else who's in Etherpad sort of in here. So
invites out to everyone who throw their email address down. Are people able to see those invitations that I sent?
I do see +6 in the call, but for some weird reason, they're not showing up here. So
I don't know if
there's folks on Etherpad, check your Google, I guess your Gmail account, and do you have like a weird Hangouts pop-up somewhere? And I guess since we're waiting for that, I know this might be done on purpose, but I know the next talk that Katie is giving is a pretty good segue for our discussion here, where she'll be talking about like how do we grade stuff, and which is, you know, one of the biggest challenges when you have a class as big as Jenny's, or even like a small class like yours. Like, it's always a pain to grade like computer or code-based work, because it might not always execute on your computer, and it works on my machine isn't really like a good answer.
Yeah, no, absolutely. Grading is a challenge. I find it a challenge because I'm teaching, like, each day is equivalent to a week long in a normal semester system, and so I give them homework every day, and then I now have to grade it every day, so I'm behind in grading. So that's it.
Well, that was another reason to do peer review, is you can get eyeballs on people's work faster than if you're always waiting for the instructor. So, yeah, marking is so difficult.
Oh, we got one.
Classes,
Woo!
or even like a small class like yours. Like it's always a pain to grade. Like
So Raina, maybe it sounds like you guys have the video call, you're watching it somewhere else because we can hear a lag of ourselves.
my machine isn't really like a good answer.
Great. I find it teaching, like, okay. So I don't think, Raina, that you need to mute this, like the live broadcast, but maybe if someone else in the room is watching it, or it's on your computer in another window, if you could close the one you were watching.
Yeah, my invite popped up in the little chat, and so it wasn't an email, it was just a little chat invite.
Yeah, it comes out like as a little chat thing, and you click it or something.
Yeah.
Yeah.
So, cool, we've all been listening.
Hello.
Hey. Yeah, sorry, we're a little dark, but that was really useful, by the way. So thanks for all the suggestions. We all found that really useful.
Fantastic. And who else do we have on the call now? John?
John, you're muted. Did Greg get an invite?
I don't know. I can send one to Greg.
I know he just put it in fairly recently, his email address, but
I'll send him an invite. I have not sent him one yet.
all right. So I guess anyone else who's just joining in, if you have any other questions or any other concerns.
Or want to make some comments.
Yeah.
Or comments.
Need to keep talking.
Yeah, exactly.
Yeah. Are there any other questions that I've been trying to do two things at once, so I don't know if I missed someone's question in the Etherpad. Greg says thanks, so does that mean he got something?
Jenny.
Yeah.
We were just wondering, since you seem like you've done this for a number of years, do you have available resources that you share or would you be willing to post anything that where you might could share some of your tips or?
Well, so I've never really, I guess my writing on like the teaching of the course is always contained in some talks.
Okay.
But so I'll put a link to my speaker deck. You can see what's available. And
Okay.
then my whole course is available online. So the whole thing.
Yeah.
There's a reasonably, it's gotten a bit out of control, reasonable web page, and then you can see the GitHub repository underneath it. But I'm not professional enough to think that that's actually navigable by anyone.
Well, I think even just looking at how other people are doing it is informative. Like, not that anybody would copy it for as a whole and try to reuse it. But I
recommend copy exactly what I'm doing.
Yeah. But just seeing sort of how you've organized it and what you've been doing and how it's evolved over the years is also quite useful.
Putting this in the Etherpad.
Okay.
If you need another example, someone had put in Ethan White's course page, which is on line 74 in the Etherpad now, which doesn't mean it'll be there when we finally finalize it.
Version this thing.
Jenny, I had another question for you. I'm Becca, by the way. So I'm curious because once I'm a professor, I'd really like to incorporate and teach classes just like you're teaching, but I feel that software and statistics for biology just changes so often. Like, how do you even choose what to teach?
So the two courses that I've taught over the past decade, one is data analysis, where I am currently chasing technology.
Uh-huh.
Kind of exhausting, but I want to learn it myself, and so I justify the time investment by saying, well, I'm learning these things, and then it'll help me in my sort of R life.
Uh-huh.
And then I've taken the opposite approach in genomics, which is we did chase the technology for years, and it was totally exhausting because like every year you had to throw out most of your material. And we sort of stepped back and decided what are the key pieces in a genomics pipeline, and what are the key statistical techniques that come up over and over and over again. Like you have to understand multiple comparison, you have to understand empirical Bayes, but we've tried to not chase specific sequencing platforms anymore. And so that was the only thing that made that course doable. So I guess it depends on which type of course you're teaching, and you can only be chasing technology in a few places at a time.
And so do you also balance your research load?
Do I what?
Are you a researcher too?
That's a good question. I made the choice to really embrace these two courses the way I do now after I got tenure, the normal way and producing the normal stuff.
Yeah.
So I don't have the same pressure to be producing the typical stuff that you would if you were junior. So for me, it is an issue, like how is this going to work at later promotions, but that's not a do or die, have a job, don't have a job kind of decision. So yeah, I would say that what I'm doing is highly incompatible with being super productive research-wise. That's like a really cynical point of view. You look at like Jeff Leake and Roger Pang and Brian Caffa and Rafa Irizarry, you know, they're doing all these online courses. I don't know if I just got lost.
Oh, no, sorry, that's just
and are super productive research-wise, so it can be done. It's just, it's not the way I'm managing to get it done, but some people do.
And you said you have TAs?
Yes. So that was critical to have like an army of TAs. So
really? How many?
I have 6 or 7, but they're not all full-time.
Wow.
So my department head sought and got funding from the Faculty of Science levels. Like, this is not just funded out of our department anymore. Like, we proved how many people are there, and they're coming from all over campus. So we actually have external funding to give it way above average level of TA support for a graduate course, and that's critical.
Yeah, because people really need hands-on help during these courses.
So we have people in class, in office hours, and then we're all on GitHub all the time answering questions, and the marking is really onerous.
And do you have undergraduate TAs too, or just graduate?
Only graduate. Yeah.
Okay, thank you.
I guess for Tiffany, how many TAs do you have, or do you have TAs, and are they graduate or undergraduate, etc.?
Yeah, unfortunately, Quest Quest does not have TAs. It's an undergraduate institute that does not have. It's private. It does not have a ton of funding at this point. It's a very new institute, so that's tough for me for marking. It's also tough for me in that I'm the only helper. I'm the only one who's giving office hours for this course. So that is a bit of it's a burden and a barrier, I think, to the student success. So I think that having good helpers, good TAs is really important for making this type of course successful.
Yes. Uh-oh, my other computer just died on me. But are there any other questions from the Etherpad, or any of you guys who just joined in? Do you guys have anything to say? Something good, something bad is typically something I always ask for on sticky notes. So.
Well, I want to answer one thing that just showed up about the demographics. I'm not sure exactly what you're getting at, but the question I'm going to choose to answer is, I need to actually get to the bottom of this, but I feel like my enrollment, and then also like the people who speak up in class and GitHub participation is like unusually, it's like disproportionately female, which I find very interesting. Like the people I have long dialogues with on GitHub, and a lot of the people who speak up in class, I just hear a lot more female voices than I do in the rest of my life on GitHub. And so I'll just present that without comment, but I think that's a nice thing. about the way Stat 545 feels this year.
All right.
So I answered the gender part of that.
Yeah.
Now that I see the full question. Are we done?
Yeah, I think we're rounding up to the top of the hour. Unless any of the other participants, Jenny and I have had a great discussion, answered a lot of questions, but I don't know if Cam or Camille or John or Raina had any comments they wanted to add to the discussion. If so, please go ahead. If not, we could.
So we talked a little bit about this in the chat there, and my university, my department, which is computer science, has been tasked with creating a course for library techs, which is a diploma. So it's not part of an MLS or MLIS program, but it's just a little bit of a data. It's probably a little closer to data carpentry. Like right now, it'll take some convincing to let us teach them to program, but they want to. Yeah. Anyway, so it's still has to be figured out over summer what's going to go into that course. So I just appreciate hearing the different delivery things and different models and assessments, and obviously different topics that are going on. So and it's supposed to be a bit more of a general course, not just for the library techs. Like any undergrads at our university will be able to take it. And so thanks very much for what you've discussed.
Great. Well, with that, maybe we'll sign off for the hour, and so Katie will be able to have her topic. Thank you all for listening. It was really wonderful discussion and all the great questions.
Thanks so much. It was helpful.
Bye.
Bye.